We now have the lecture on optimization problems. Kung medyo mahina, pwedeng pakilakas lang ng konti yung volume. Pagpasensya nyo na rin kung merong mga konting ingay while recording this lecture. Okay, let's now start. For example, suppose a company has determined that in selling X units of a particular product, the total revenue R in pesos is given by R of X equals negative X cubed plus 450X squared plus 52,500X. How many units of the product should the company sell in order to have maximum revenue? To answer this question, we want to find the maximum value of the function R. So we get the derivative of R. R prime of X equals negative 3X squared plus 900X plus 52,500. This one is equal to negative 3 times X squared minus 300X minus 17,500. This is also equal to negative 3 times this one. Set natin yung R prime to be equal to 0. So that negative 3 times X minus 350 times X plus 50 equals 0. So we get X equals 350 or X equals negative 50. Ito yung mga critical numbers ng R. But since X is the number of units of a particular product, X must be greater than 0 or positive. So the critical number of R that is positive is 350. Okay. We now get the second derivative of R, which is negative 6X plus 900. Substitute X equals 350 here. We get R double prime of 350 equals negative 6 times 350 plus 900. Negative 6 times 350 is negative 2,100. Adding 900, we get negative 1,200, which is less than 0. Since R prime is 0 and R double prime is negative, then by the second derivative test, R has a relative maximum at X equals 350. So when X equals 350, maximum ngayon yung revenue. So 350 units of the product must be sold. Okay. Any problem where we get the maximum or minimum value of a quantity or a function is called an optimization problem. We now mention the steps in solving optimization problems. First, if possible, draw a diagram. Next, assign variables to all quantities involved. Next, identify the quantity to be maximized or minimized. Para masabi natin yung mga iba pang steps, tawagin natin yung quantity na yon to be Q. Next, formulate an equation involving the quantity Q to be maximized or minimized and the other variables. Then express Q in terms of a single variable. Let's say X. Then determine the constraint of X, or the set of all possible values of X, considering the physical restrictions of the problem. So kunwari dun sa example kanina, we only considered positive values of X, since X is the number of units of a product. Then find the desired maximum or minimum value using the appropriate techniques. Using critical numbers and then using the second derivative test. Pwede rin gamitin yung first derivative test to get the maximum or minimum values. Let's have another example. The product of two positive real numbers is 288. Minimize the sum of twice the first and the second. Before we solve this problem, try to understand this problem first. Let's now solve this problem. Let's assign variables. Let x be the first number, y be the second number, and s be the sum of twice the first and the second. We now identify the quantity to be maximized or minimized. We want to minimize s. Okay? Gawa natin yung equation, yung s, x, and y. Since s is the sum of twice the first and the second, the first number is x, and the second number is y, then s equals 2x plus y. We now express s in terms of x. So we express y in terms of x. Since the product of the two numbers must be 288, xy must be 288. So that y equals 288 over x. Substitute natin yung 288 over x dun sa y dito. So we get s equals 2x plus 288 over x. So magiging s of x siya if we treat s as a function of x. This is also equal to 2x plus 288 x raised to negative 1. We now get the constraint. Since we have positive here, x must be greater than 0, or the value of x must come from the open interval 0 to infinity. We now get the derivative of s. Derivative of 2x is 2, and derivative of 288x raised to negative 1 is negative 288x raised to negative 2. We can write this as 2 minus 288 over x squared. Setting s prime to be equal to 0. Then 2 minus 288 over x squared equals 0. From this equation, 2 equals 288 over x squared, or x squared equals 288 over 2, or x squared equals 144. Solving for x, we get x equals plus or minus 12. Pero kailangan x is positive, So x must be positive 12. So the critical number of s on this interval is 12. Okay? We now get s double prime. So yung derivative nito. S double prime equals 576x raised to negative 3. Since negative 288 times negative 2 is 576. This is also equal to 576 over x cubed. If we substitute x equals 12 dito, s double prime of 12 equals this one, which is equal to 1/3. This is positive. Since s prime is 0 and s double prime is positive, then by the second derivative test, s has a relative minimum at x equals 12. Okay? So the minimum value of the sum is the value of s when x equals 12 or s of 12. Substitute x equals 12 dito. We have 2 times 12 plus 288 over 12. 2 times 12 is 24. 288 over 12 is 24. So, the minimum value of the sum is 48. Okay?